And we're going to start with a roll call. So if you want to administer that?
Sure, we just wanted our members to quickly introduce themselves.
So I'm Martin Kuldorf.
Joseph Hibbelin.
Robert Bloom.
James Pagano.
Recep Levy.
And we have two members remotely, I believe.
Vicki Pepsworth.
Good morning. This is Cody Meissner.
And we have a slight change in the agenda. We did not finish the discussions of the RSV yesterday. And we are going to, I believe, today, we will, the chikungunya, we will do just a 5-minute presentation on that. And then we'll leave that for the next meeting, the rest of that. So back to the RSV, we have 2 votes to be made. But we didn't finish the discussion yesterday. So I just want to stress that most of the presentations yesterday was mainly about the maternal vaccination, as well as the already approved nirsevimab monoclonal antibody. The thing that we're voting on is not neither of those 2 products. We're voting on a second alternative monoclonal antibody. So it's not a vaccine, it's a monoclonal antibody called clasrovimab. But I want to give the members here opportunities to ask questions about the presentations yesterday and have a discussion about this. So please. Dr. Levi.
So good morning, everybody. First, let me thank again for the very detailed presentation yesterday about the RSV products. I think there's a consensus that RSV is a serious illness that poses risks to babies, especially young babies in their early stages of life, and particularly to vulnerable babies that have either some comorbidities and underlying conditions and or early preterm birth. So I think that we are all hopeful that these therapies are going to allow us to provide them better care and hopefully prevent serious hospitalizations and deaths. That said, I think that we now have 2 products, one that is already approved and one that we are about to approve. And I took the opportunity to look through what the clinical trials that were conducted on all of these products suggest. And I would like to share share data that I found, and would be very happy to hear the reactions of our colleagues at the CDC about what do they make out of that data in terms of safety concerns. So the main phase 3 trial that was conducted on healthy children on the previous product, the nirsevimab, it was the MELODY trial, and it was conducted in a ratio of 2:1 for the immunized children and babies. The number of deaths in that trial were 5 in the immunized children and 0 in the placebo arm. That was against placebo, the trial. And the serious adverse events were balanced, but I think it's important to note that that includes RSV hospitalization. So that includes also the benefits that we are expecting to get from the product, which means assuming that serious adverse events often involves hospitalization, that there is something else that is compensating for the hopeful benefit. And particularly there was some at least some imbalance in the nervous system serious adverse events. Now, when I look on the other trial, the medley trial, which was for babies that were early preterm and babies with comorbidities, again at a ratio of 2:1, but this time not against placebo, but against the palivizumab, which is an existing treatment. The imbalance of the deaths continues with 5:1. Again, the serious adverse events are balanced, and again there is an imbalance in the nervous system serious adverse events, as well as in gastroenteritis cases. And interestingly, 2 of the babies that died in the Melody trial were from gastroenteritis, and these are healthy babies, which is, based on my discussions with doctors, it's a pretty rare event. And then there is a third trial that is now has been run in Europe, the Harmony trial, in three countries, France, UK, and Germany, that doesn't have any deaths in either one of the arms. Again, it's against placebo, or not against placebo, against lack of treatment, so it's an open label one. Actually, the serious adverse events rates are higher in the vaccine, in the immunized, and again, there is a serious imbalance on the nervous system, serious adverse events. By the way, I just want to recall my question yesterday about a more refined quantification of the benefits in terms of number of hospital days, ICU days, and so forth. It turns out that the protocols of all of these 3 trials do suggest that the vendors have to report on those metrics, and the only thing that I found is an early reporting from the Melody trial that actually suggests that the immunized babies stayed longer in the hospital once they were hospitalized, which could raise the concern of potentially disease, immunization enhanced disease. Now, if I look on the clinical trials of the product we are supposed to vote on today, this is the clesrovimab. Again, a trial of 2:1 with healthy children. There's again imbalance on the deaths, 7-3. Against this, serious adverse events are balanced despite of the fact that they capture also RSV hospitalizations. The nervous system serious adverse events is 25-4, and the gastroenteritis seems to be 30-10, again imbalanced. And another important point that I think we should think about is that this product is given in a 105 milligram dose. The previous product that was already approved is given either at 50 milligram or 2 doses of 50, which is 100 milligrams. So it raises the questions about those relationship here. And it seems that there's also an ongoing trial on the current product, again with unhealthy children with comorbidities, where the only reporting that I saw so far is from Merck, but it does report on 8-4 deaths in the, again, more in the immunized arm. So when I look on all of this, I would like to hear maybe from our colleagues at the CDC, should we not be concerned that maybe there are some potential safety signals now? That these are small numbers, so clearly you cannot establish a safety signal based on that, but should we be concerned? And when I considered the post-marketing analysis we've seen yesterday, which was, by the way, well done, very, very nice analysis, but focused on very specific adverse events and on a very short period of time after the immunization, and does not consider death. So I just want to ask both my colleagues in the committee, but also the CDC colleagues here, should we perhaps be concerned that there are, side by side to the benefits, alongside the benefits, we also have some things that you should be concerned about. So thank you. Sorry for taking a long time.
Thank you for those comments. Is anybody from CDC who would like to respond?
No, he's not getting cut off. It's just that now it's a lag.
Yes, thank you. I think since these are questions related to the clinical trials, if Merck is on the line and would like to answer the questions about their data.
Again, the trial 2-to-1 with healthy children.
We also have a hand in our room, in case you can't see it. Yeah. Yeah.
You might be muted.
Hi, can you guys hear me?
I think disconnect.
Hi, this is Mark. Can you hear me?
Yes, we can hear you now.
Good morning. This is Dr. Anushiwa Sinha. I'm speaking from Merck Research Labs, and thank you for the opportunity to address the question. As was mentioned earlier, clesrovimab is a passive immunization. It's a monoclonal antibody that was recently licensed by the US FDA and indicated for the prevention of RSV disease in infants as they're entering their first RSV season. The review by FDA was extensive and included both our safety and efficacy data. And as has been provided to the ACIP working group, during their deliberations in November last year, we've provided extensive materials concerning the topic under discussion. It's important to note that throughout our clinical trial conduct, there was extensive analysis of these events, and importantly, none of these events were deemed by investigators to be associated with RSV or with the interventions given to the infants. Another important point is that there were no trends identified either. I'm sorry, there's some background noise. Can you guys still hear me?
We can hear you. For everyone else, please mute your microphone.
Yeah, so I'll just roll back a little bit from when the background noise started. So importantly, each of these events was evaluated by the investigators, and none were deemed related to either RSV or the intervention administered to the child. No trends were identified in terms of cause, system organ class, clustering in terms of time. That means there was no temporal trend either. I do want to emphasize that the first trial mentioned, the healthy infant trial, that's protocol 4, also called CLEVER, was randomized 2-to-1. So when counting events, one must be aware of that 2-to-1 randomization. Thank you.
Thank you very much. Okay, Brianna Barnes, please.
Hi, could we pull up slide 53 from the ETR deck? This is Danielle Julia from the maternal pediatric RSV work. We have a slide prepared for this question. Sorry, are you able to hear me?
Yes, we're pulling it up.
Thank you. I guess I will say sort of while it's being pulled up. So we did evaluate deaths as a potential harm for clesrovimab, as Dr. Sinha mentioned. These were measured in the 365 days post-immunization of the clesrovimab pivotal phase 2b/3 trial. They were balanced between groups, between the clesrovimab and the placebo arm, because if you note, the study design was 2-to-1 to the intervention. So while there were 7 events in the clesrovimab arm and 3 events in the placebo arm, this is what we would expect if we randomized 2-to-1. There was no pattern observed in cause or timing of death related to the intervention. And I actually think we can turn it to FDA to comment more on their safety review of this product.
I didn't know if you wanted me to comment as the ex officio, but so I did want to mention that this product was approved by CDER, and so I as ex officio, I work in CBER, and so I would like to be able to take the opportunity to get a comment from CDER rather than comment on their behalf about the review, if that would be acceptable.
Is there anybody from CDER, FDA CDER on the call?
Again, awesome.
Hi, hello, can you hear me?
Yes.
Hi, this is Amy Hodowanik from the Division of Antivirals in CDER. I don't have much to add beyond Merck's summary, but I will say that we did review all of these narratives very carefully, and we did not observe any trends or clusterings in causes of death, and nothing that seemed suggestive of a drug-related cause of death in any of these cases. And similarly, as has been pointed out, this is a monoclonal antibody, and generally this class is well tolerated with limited toxicity.
Thank you so much, Dr. Levi.
Yeah, thank you for the responses. I think I acknowledge the 2-to-1 ratio of the trial, but I think that one trend I would like to ask you about is that you have here 4 trials. In all of them, the numbers of the deaths are going in one direction. So wouldn't that be some kind of a trend that we need to think about? Because I understand also, and I think we agree that these trials are very small. They are not powered to actually detect a lot of signals unless they are very, very strong. But when you look on 4 different trials and you see the same patterns or similar patterns, doesn't it tell us something of 2 very similar products, right? So I'm just curious to hear your thoughts about this. Thank you.
So if there's no response from FDA either, so these 4 trials.
Hello, this is.
Please go ahead.
This is Amy again from CDER. I wasn't sure if that was directed to us necessarily, or to the company directly. But yes, it does. The numerical numbers go the wrong direction in these studies. But if you look at the percentages here, it's 0.3 versus 0.2%. We would not consider that to really be a difference in the death rate between the 2 arms. These are very small numbers, and so we did not find that to be any sort of meaningful trend or difference between arms. And again, we put a lot of weight in our review of the narratives for these cases, and looking at potential biological plausibility in terms of the causes of death and the receipt of clesrovimab.
So this is Martin Kulver. So I have a comment. So in these 4 trials, I think 3 of them are for the nirsevimab, which has already been recommended by ACIP in a previous meeting, which we are not making a vote on. There was actually more of an imbalance, and I think it's critically important to monitor that as we move forward about the mortality and other potential adverse reactions to nirsevimab. But we're not voting on that product right now. So we're voting on clesrovimab, and excuse me for not always pronouncing these things correctly. And I think for that, the mortality was actually quite balanced, as we can show on the slide here. So it could be potentially that this new product that was just recently approved by FDA, it could even be that it is superior to the nirsevimab that's already been recommended, but we don't know that, so that's something that would have to be looked at, and it's important, I think, to look at as we go through this next season of these products. Dr. Levi?
Yeah, I just want to clarify that my understanding is correct. So is there an ongoing trial now for clesrovimab that the current reporting is 8 deaths versus 4 between the immunized and the non-immunized, the ones that get the standard care? Is that a fair understanding on my part?
This is Amy from Cedar again. I would
They're gonna
defer
say
to
whatever
Merck
they
to provide
need
an
to say
update
to
on
defend
ongoing
their
or recently
actions.
completed trials. Thank you.
And make a big farmer rich.
This question is directed to the Merck. If you can respond, please.
Hello, this is Merck again. Can you hear me?
Yes, thank you.
It's Dr. Sinha from Dr. Anushiwa Sinha from Merck Research Labs. Indeed, in addition to the Healthy Infant Study, Protocol 4, also known as CLEVER, that you're looking at on the slide here, we have an ongoing trial in at-risk infants. That's Protocol 7. It also goes by SMART. And in that study, infants are randomized 1-to-1 to receive either clesrovimab or palivizumab. We did an interim analysis to support our FDA licensure. And in that interim analysis, as you've noted, there were 8 deaths in the clesrovimab arm and 4 in the palivizumab arm. Each of those deaths was extensively analyzed and was under review by our independent external data monitoring committee. As noted with the Healthy Infant Trial, Protocol 4 that we reviewed earlier, there was no death that was deemed associated with the study intervention. There was no clustering in terms of causality, system organ class, or time of event, that is to say temporality. And as noted by other speakers, these events are rare, and the study is ongoing. This was an interim analysis. Thank you.
Thank you for that. I would also like to know if Dr. Meissner have any comments on this or thoughts. Dr. Meissner has been a member of the working group on RSV and continue to be.
Thank you, Dr. Kolar. These are all issues that were extensively discussed in our work group, which included over 60 members. We went through the details very, very carefully. And I think I appreciate Dr. Retsev's careful review of the records, but the work group is comfortable with the results from the different clesrovimab trials. I will say that studies in high-risk infants, including preterm infants, that's a very fragile group, and unexpected deaths unfortunately occur in both groups. I don't believe there was any evidence, as has been stated, that there was an imbalance or any pattern associated with adverse events, serious adverse events among the clesrovimab recipients. I think that the work group was very comfortable making the recommendation that they did.
Thank you so much for that. And I also want to take this opportunity to, really thanks to the work group who's been, and that's not just Dr. Meissner, many other people in that work group have worked very, very hard on this. I would also really like to thank my fellow members of this committee, because in the presentation yesterday was mostly about the maternal vaccine and the nirsevimab, which has already been recommended by a previous ACIP meeting. But the members of this working group has sort of gone beyond that information that were presented yesterday to also look in very great detail at the clesrovimab, which is the thing that we're voting on today, and that was just recently approved by FDA 2 weeks ago. So I really want to commend my fellow members of this committee for stepping in and really examining these very, very thoroughly. Also, if there's any other ex officio members or liaisons to this committee who wants to comment, can you please do so by raising your hand, and then we can have you also comment. Dr. Malone.
I'd just like to say that there's been very, very active discussion and consideration within the committee, just for the record, concerning this product. It has been very actively debated internally, and I'm satisfied that given the short period of time we have to address this, that I'm comfortable that we have sufficient information, and the committee itself has rigorously, to the best of its ability, considered these various aspects and has had an opportunity, despite the short time frame, to investigate and discuss and also be briefed on the underlying issues in science. Over.
Thank you. Are there any requests for comments from? Okay, so we have one. Robert Hopkins, please.
Good morning. This is Dr. Robert Hopkins from the National Foundation for Infectious Diseases. RSV is the leading cause of infant hospitalizations in the U.S. The scientific evidence and data clearly support the use of maternal RSV vaccines during pregnancy, as well as monoclonal antibodies to help protect infants born to mothers who are not vaccinated during pregnancy. NFID urges ACIP to ensure that any changes made to RSV recommendations are evidence-based. We remain committed to protecting infants from serious RSV-related outcomes. Thank you.
Thank you so much. So I think we are ready to proceed to Dr. Lama.
Yeah, one sentence. I'm a scientist, but I'm also a father of 6 kids, 6 children. And I think it's also important to put yourself in the shoes of a parent. So I'm trying, one of the things that makes me kind of beyond the science, the data, I was asking myself, what if I would be just a parent for a baby? And I had the amazing opportunity to be in that situation 6 times. And I know all the information. How would I think about this dilemma? And I think if I had a baby that was born early or had, God forbidden, some underlying conditions, knowing the threat that RSV can pose to a baby like that, I would probably use these products to protect my child from this disease, because it could actually cause deaths to the baby. On the other hand, if I was the father, and luckily I was the father of a healthy child that was born on time, that knowing all of this, I would be concerned to use that. And I think that I understand that we're trying to reduce the burden of hospitalizations, and these are all very important metrics, but I think we also need to ask ourselves what the parent would say given this data. And I think that most parents that have a healthy baby would be concerned to use a new product against the disease that has turned out in the past to be quite tricky against immunization and vaccination. I think they would be concerned. And as a father, I can feel that I would be concerned. I just wanted to share that. Thank you.
Good man.
Thank you for that. We have Vicky, Dr. Pepsworth, who is a member of the committee.
Hi. I would like to see again the safety and effectiveness outcomes data that are broken out by infant health status, especially gestational age. So I would just like to understand the difference between the health outcomes of very sick infants and healthy children. The other comment I have is, do we have data on effectiveness and particularly safety when this product is given within the context of the current schedule? Because depending on when the product is given, it could also be given with several vaccines, including hepatitis B, rotavirus, DTaP, Hib, pneumococcal, polio, COVID, and flu. So do we have information on simultaneous administration with these other products as it relates to safety outcomes? Thank you.
That's a very important question, and I think the working group have looked at that. Could you address that, Dr. Meissner?
Yes, I'd be delighted to address that, Dr. Caldor. First of all, it's a question of how far we want to go in this discussion. But remember, approximately 80% of the children who are hospitalized for RSV, which is approximately 2 to 3% of the birth cohort, are perfectly healthy children who don't have prematurity, who do not have congenital heart disease, chronic lung disease. These are infants who almost invariably become symptomatic with their RSV infection. Approximately a third of RSV infected children have lower respiratory tract infections, which necessitates visits to their pediatrician's office or to the emergency department, even if they're not admitted. So we cannot identify who among those 80% are the children who are going to experience severe lower respiratory tract disease. Clearly there are factors, people are looking at that aggressively, but we cannot identify who is most likely to benefit from administration of clesrovimab or nirsevimab. The second point is death is very rare in the United States among infants due to RSV. There are probably fewer than 100 deaths a year in the United States due to RSV in very young children, and those are primarily occurring in children who have other comorbidities, which I just mentioned.
Underlying conditions.
As people have noted, it would be nice if we could use death as an endpoint, but there aren't many deaths, so it's not possible to do that. So the best primary endpoint that can be established is hospitalization rates. We can also look at rates of ICU admission, but the data is consistently demonstrating that these vaccines, and they're really not a vaccine as we know. I think that's why there's confusion. These are monoclonal antibodies that are passively administered. They're not a vaccine. It's not an antigen which stimulates the host's immune response. So and then we haven't talked about maternal vaccination. If a woman decides that she does not want to receive an RSV vaccine during gestation, between 32 and 36 weeks at the time of the year when it's most beneficial, then the alternative is to administer a monoclonal antibody to the infant at birth. And my response to Retsa, is that, Dr. Levy, I would, if I were your pediatrician, I would strongly recommend that your wife either receive the RSV vaccine or a monoclonal antibody at birth. There are various issues that go into that decision-making process, but one or the other should be administered, or at least be available to every woman while she's pregnant. And I think that we've come so far in the last few years in making these products available. And again, it's really a result of the extraordinary investigations that Barney Graham has conducted largely under NIH support, and his colleague Jason McClellan, that we've gotten to this point with the monoclonal antibodies and the vaccines. These are truly remarkable products. They are safe and they're effective. And I don't think there's any further data that needs to be presented. These, I think we're in a position, the work group has spent an enormous amount of time. The FDA has spent an enormous effort looking at safety and efficacy, and it is simply not an issue here. Over.
Thank you. Dr. Meissner, can you also address the question by Dr. Pesworth about concomitant administration of the monoclonal antibodies at the same day as one of the vaccines in the Chicago schedule? Because I think the work group did look at that.
Yes, and I will go. Remember, there are three monoclonal antibodies. Palivizumab was the first generation monoclonal antibody that became available, I think it was in 1999. And then clesrovimab and nirsevimab are second generation or antibodies. They contain certain the YTE mutation. There are 3 amino acid substitutions in the FC fragment that prolong the half-life of these monoclonal antibodies so that a single dose is protective throughout the RSV season. With palivizumab, that was not the case. A dose had to be administered every month for 5 months to cover those infants during the RSV season. We've advanced far beyond that. And we have a great deal of experience with palivizumab administration because it's given over a 5-month period. And there's absolutely no interference with any of the standard routinely recommended childhood vaccines. So I'm very comfortable reassuring people that that is not an issue. Is that?
Yes, thank you so much. Thank you so much. We have a comment or question by Jason Goldman. Dr. Goldman, please.
Thank you. Jason Goldman, American College of Physicians, speaking as an individual. Dr. Meissner said much of what I was going to bring up, so thank you for those eloquent comments. I just want to reflect, that as physicians who actually take care of patients, the medical doctors, the clinicians, we see the effects of disease and if they are untreated and not prevented. And certainly those who are healthy get sick. And that is not a sole criteria for saying something does not work, that it is only given to those who are at risk. Because we do not know our risk until we actually experience the disease. So healthy children do get RSV, do get sick, and some end up hospitalized or even die. So it is important to approve this very important intervention, which is not a vaccine, but is passive immunity. And as a father of 2 children, I wish they had this when they were born. This is a tremendous advance for medical science, and I urge the committee to approve and pass this resolution so that we can continue to protect our children and keep them healthy. Thank you.
Thank you, Dr. Goldman. And we have Dr. Sarah Meyer from CDC.
Hello, yes, I wanted to return to Dr. Pebsworth's question about co-administration. We do have real-world evidence from the vaccine safety data link that Dr. Daly presented yesterday. A very high proportion of those infants had received simultaneous vaccination with another vaccine, and I'll turn it over to Dr. Daly to go through those details from our real-world data.
Thank you, Dr. Malone.
This is for Dr. Meissner.
Sorry, I was trying to tag Dr. Daly if he would like to have more details.
Sorry, my fault. Thank you.
So this is Matt Daly. Can you hear me okay, Dr. Colder?
Yes.
The nirsevimab safety evidence that we presented yesterday was in 74,000 infants exposed to nirsevimab, and so then that's roughly 20 times the size of the original clinical trial or more, and that's in routine practice. And so as I summarized in the slides yesterday, 20% of the neonate cohort received same-day hepatitis B, and 84% of that older age group received simultaneous same-day vaccination with routine vaccines. And so essentially the safety evidence that I presented yesterday, in particular for that group who were 37 days to less than 8 months of age, does represent safety with simultaneous vaccination. Over.
Thank you. Dr. Malone?
One of the concerns that I've heard raised by colleagues in the medical community, primary care providers, is that with these products, we may be merely delaying the potential for disease in this population to the following year, so year 2 of birth rather than year 1. Dr. Meissner shared with me current understanding of the pathophysiology. I'm asking Dr. Meissner, can you address this issue of the terminal microairways and the implications for this product and state of development of the child? Over.
Yes, thank you, Dr. Malone. Just very succinctly, the most severe RSV disease we see is in children in the first 90 days of life. Those are the children most likely to be hospitalized. And the reason that they're at increased risk is because they're bronchioles. That is the little air tubes that conduct air into the alveoli, the small pockets in the lung where carbon dioxide and oxygen are exchanged, become inflamed with an RSV, lower respiratory tract infection. That inflammation is enough to completely occlude their airways because they're so narrow in diameter in a very young child, particularly a preterm child. By the time a child reaches the second year of life and beyond, those airways are larger. And so a small amount of inflammation in the airway in a child in the second, third, fourth, fifth year of life is much less likely to result in the same degree of respiratory distress that a newborn might experience. So really, the monoclonal antibody for healthy children is given to prevent the infection from occurring at the highest risk period, that is the first 90 days. Now, one of the questions that's been asked, and I believe has been answered, is that these monoclonal antibodies still enable the child to be infected, but the child does not get lower respiratory tract infection. And so the child builds up immunity against RSV, and that may very well protect him or her in the second year of life. Even if it does shift the RSV infection, if there is age shifting to the second year of life, it's not as problematic because, again, the airways are larger in diameter and can tolerate a small degree of inflammation that occludes the lumen of the airway. Over.
Thank you very much, and I think we're going to proceed to the voting. So the draft vote is ACIP recommends, and there's actually two of them. The first one is ACIP recommends infants aged less than 8 months, born during or entering their first RSV season, who are not protected by maternal vaccination, receive 1 dose of clesrovimab. And I want to just clarify that this is not in addition to the nirsevimab, which has already been recommended. So it's basically that the child will receive either clesrovimab or nirsevimab, or the mother would have received the vaccination during pregnancy. So there's one of these three should be done. It's not in addition to that, it's instead of. Do we have a motion for this, Dr. Malone?
I move for approval of this draft recommendation language. Over.
Thank you. And do we have a second?
Yes, I second it.
Okay, we have a second, so let's vote then. And why don't we start with Dr. Malone?
Vote yes.
Dr. Hebron?
I vote yes.
Dr. Pagano?
Yes.
Dr. Lebe?
I vote no. I just want to clarify that my objection is based on the fact that I don't feel this is ready to be administered to all healthy babies. I think we should take a more precautionary approach to this. But I respect the discussion and the opinions of my colleagues. I vote no. Thank you.
Thank you. Dr. Meissner?
Yes.
Dr. Petworth?
I vote no.
And as I'm article, I vote yes. So we have 5 votes for yes and 2 votes for no. And we also have a second draft vote, which is, this was presented yesterday at the meeting, approve the updated vaccines for children resolution for prevention of RSV. So we'll do the same order. Dr. Malone?
I wasn't aware that we were going to have this vote.
It is essentially the same vote. It's just making sure that this product is available in the Vaccine for Children's program. That is my understanding. Is that correct?
Yeah, so can I hear the actual language that I would be voting on?
We'll need to pull up the resolution language. I think if we can go to slide.
Dr. Kuldorf, can I make a comment?
Please do.
And I appreciate Dr. Malone's questions. This is extremely important that VFC cover this product. It is very important to ensure equity in our country so that all children have access to these monoclonal antibodies. It would not be right, because these are expensive products, that only well-insured children, or in families that are well-insured, have access to this product. I think we've all discussed the fact that this is an effective product, and I would strongly encourage everyone to make it available to all children. Over.
Yeah, so, Cody, I just was surprised because this language was not in our briefing document for approved language for voting, but I saw on the prior screen that was just displayed, I know my confusion is resolved, because the issue here is just the nuance of similar approval, but specifically for the VFC program, if I'm understanding correctly. Is that the case?
I can clarify. So typically after a vote occurs on the recommended product, then there is a resolution by the committee to add that to the formulary for the FC program.
Thank you for the clarification. Malone votes yes.
Well, hold on a little bit. Dr. Daskalakis.
Totally just a point of order. I'm not sure if we necessarily have a motion to approve and a second on this vote yet. So you may want to do that as well.
Malone,
one other comment is also about 50% of American children get their vaccines and immunizations through VFC. So that's the background. Thank you.
Yeah. Malone moves. Okay. I second.
While voting, can you please state your name, whether you have conflict of interest, and then you vote?
Malone votes yes.
And do you have a conflict of interest?
No conflict of interest.
Thank you. Dr. Hibbeln?
Dr. Hibbeln first appreciates the clarification. Secondly, I vote yes. Third, I have no conflicts of interest.
Dr. Pagano?
I vote yes and no complications, no contradictions.
And your name?
James Pagano.
Dr. Vela?
Recep Levy, I don't have any conflicts of interest. I think that we need to ensure access, so whatever kids need to actually use that product, of course I think we need to make sure that they get it, so yes.
Dr. Meissner?
Cody Meissner votes yes, and I have no conflict.
Dr. Petworth?
Sorry.
These people are
Sorry, I vote yes, and I believe that I am required to read a statement. I don't know whether I have a conflict or not, but as required under the ACIP policies and procedures, I'm also disclosing that I own shares in a healthcare sector fund that includes holdings relevant to the ACIP, including vaccine manufacturers. However, the amount of that shareholding is under the Office of Government Ethics regulatory de minimis amount. I understand that I therefore can fully participate in the ACIP meeting.
Of course you can. And you can vote yes. Because
Thank you. Can you state your name?
At least she admitted it.
Thank you. My name is Martin Kuldorf. I have no conflict of interest, and I vote yes. So we have a vote of 7-0 on this, so thank you. And again, I really want to stress, thank you very much for the working group, for the enormously thorough work you've done. Thank you for the CDC staff. And especially thank you for my fellow members of this group who, at very short notice, have really immersed yourself into this issue of clesrovimab, and it was only approved by FDA, I think 16 days ago. So there was a very short time to very quickly get all the information that was needed, both the presentations yesterday, but also a lot of information in addition to that. So thank you so much.
Dr. Kuldorf, can I make one comment? I would just like to recognize the contributions of Jefferson Jones, who has led the work group throughout this procedure and has just done an exemplary job. Over.
Thank you, and I should also stress that the votes indicate that the recommendations are approved. So thank you very much.
So I just want to encourage our CDC colleagues to, we have post-marketing data now. I think we should hopefully see soon analysis on regarding deaths and more broad kind of analysis on broader set of potential adverse events. Again, I think we want to make sure that alongside the benefits, we understand the risks, regardless of the decisions of whether to use it or not. We need to have transparency about what is the trade-off here. And I think that the analysis yesterday was very, very well done, but limited to certain periods of time and certain specific adverse events. I think we need to hopefully expand that. Thank you.
Good man.
Thank you. And post-market safety surveillance is incredibly important for all vaccines. This is not a vaccine, it's a monoclonal antibody. It's equally important to do the post-market surveillance, safety surveillance for not only the clesrovimab, but also to continue the safety surveillance for nirsevimab that has already been recommended previously. So thank you so much. I appreciate that. We will now continue to the next item, which is influenza vaccines. And the first presentation, the introduction, is by Dr. Lyle Peterson at CDC. So, thank you.
Okay, so
sorry, I think the introduction is. I got the name wrong. The introduction is by Vivian Dugan. I'm very sorry. My apologies.
Yeah, no problem. Good morning, everyone. I'm Dr. Vivian Dugan. I am the director of the Influenza Division here at CDC. Just briefly to review.
Can you put the microphone a little bit closer?
Sure.
Thank you.
No problem. How's that? Is that better? Okay.
Her name is Vivian Dugan.
So,
on the plaque it says presenter.
Okay.
Her name is Vivian Dugan.
So good morning, everyone. I'm Dr. Vivian Dugan. I'm the director of the Influenza Division at CDC. I'll give a brief review of the presentations in the influenza session. So we are going to have 5 presentations. The first is a presentation on flu block in older children and adolescents, immunogenicity and safety, presented by Dr. Pedro Folgati from Sanofi Pasteur. Next slide, please. And then I will give presentations on the next 2 topics. That's estimates of influenza burden and burden averted through vaccination, and then a brief 2024-2025 season update and the proposed seasonal influenza vaccine recommendations for the 25-26 U.S. influenza season. Then we'll have a presentation regarding thimerosal and vaccines by Lynn Redwood, RN, MSN. And finally, proposed recommendations regarding thimerosal and vaccines by Dr. Martin Kuldorf. Thank you, and back over to the chair for the next presentation.
I don't see a presentation for somebody talking about natural immunities and building up a natural immune system instead of being inoculated with all of this stuff. Where's a presentation to show the studies and the data that would support a natural
So we now have a
response?
presentation by Dr. Pedro Folgati, please.
Natural immunities.
Good morning. Can you hear me okay?
Yes.
Okay. So good morning, I'm Dr. Pedro Folgati. I'm a Global Clinical Development Director at Sanofi. And today I'm joined by my colleague, Dr. Tinius Maret, North America Medical Head for Influenza and COVID vaccines. I will be presenting today the results of our phase 3 immunobridging non-inferiority trial of the quadrivalent recombinant influenza vaccine, which is licensed as Flublok in older children and adolescents compared to adults. Next slide, please. For full disclosure of my conflicts of interest, I am a full-time employee of Sanofi and I do hold shares in the company. Next slide, please. So I would like to start by giving some background to the technology behind Flublok. Recombinant proteins have been established as a proven approach to vaccine development against infectious diseases since the late 80s and have a track record of safety and effectiveness across different pathogens, including hepatitis B, HPV, zoster, COVID-19, and influenza. In the context of influenza vaccines, this technology offers some key advantages. The use of recombinant technology ensures the sequence integrity of flu antigens consistent with FDA-selected strains for seasonal vaccines. The manufacturing process is independent of egg supply and does not require culture or handling of live influenza viruses. There is no egg adaptation of the flu virus in this process. And finally, the recombinant influenza vaccine does not go through an inactivation step, preserving the native hemagglutinin conformation of the wild-type virus which is best suited for optimal protective immune responses. Next slide, please. Before I share the results of our pediatric study, I would like to highlight some of the key established clinical evidence we have for Flublok. In a phase 3 randomized control efficacy trial in adults aged 50 years and above, we demonstrated 30 to 43% enhanced protection against virologically confirmed symptomatic influenza disease when compared to a US licensed standard dose inactivated influenza vaccine during a predominantly H3N2 mismatch season. In a phase 3 immunobridging study conducted in adults aged 18 to 49 years old, comparing Flublok with the same US licensed standard dose inactivated vaccine, showed non-inferior immune responses to 3 out of 4 strains. The trivalent formulation was first licensed in 2013, followed by approval of the quadrivalent version in 2016 for those aged 18 years old and above, and the label has now been updated and approved by the FDA to include children from 9 years of age and older, based on the data we're presenting today. There were 38 million doses distributed until last year, with updated figures now amounting to over 43 million doses of Flublok distributed across the globe as of 31st of January 2025. The vaccine has an established safety profile, is well tolerated, with no safety signals identified to date. Next slide, please. But the study we're presenting today was conducted in the context of our pediatric study and investigational plans for Flublok that were discussed and agreed with the FDA and international regulatory authorities. I will now provide an overview of the trial design. So this was a phase 3 multi-center, open-label and non-randomized immunobridging study conducted in 36 sites across Spain, Poland, Czech Republic, and the United States. Up to 1,334 healthy children, adolescents, and adults aged 9 through 49 years old were planned to be enrolled in the trial. All participants received a single dose of Flublok. Our primary objective was to demonstrate the non-inferiority of immune responses in the 9 to 17 years old group compared to the immune responses in adults where vaccine efficacy had already been established from previous studies. Immune responses were assessed based on hemagglutination inhibition, antibody titers, and seroconversion rates at 4 weeks after vaccine administration. And the key secondary objective was to describe the safety profile of Flublok by age group. Next slide, please. So this figure on the left represents an outline of the participants' journey in the study. They came for their vaccination visit on day 1, where a blood sample was drawn at baseline, then had a follow-up safety phone call at day 9, and attended the clinic again at day 29 for a safety review and a second blood draw. Participants were then followed up for 6 months after the study intervention. Solicited or predefined and actively monitored local injection sites and systemic adverse events were collected for 7 days, with unsolicited events and medically attended adverse events being collected for 28 days. Serious adverse events and adverse events of special interest were collected throughout the study period. There were 2 key exclusion criteria that I would like to highlight, and these were the receipt of any other vaccine in the 4 weeks before or after enrollment, except for COVID vaccines, which were allowed at least 2 weeks before or after the study intervention, and the receipt of any influenza vaccines in the 6 months preceding enrollment. The last point I would like to cover on the clinical trial design refers to our statistical considerations. Our trial success was based on both geometric mean titer ratios and seroconversion rates at day 29 for each of the 4 influenza strains. The study was designed with a standard overall 80% power to demonstrate non-inferiority of the immune responses based on 8 non-inferiority tests. The statistical criteria to demonstrate non-inferiority for geometric mean titer ratios was that the lower bound of the 95% confidence interval was greater than 0.667, and the lower bound of the 95% confidence interval for the difference in seroconversion rates between the groups had to be greater than -10%. Next slide, please. So here's the participants' flow diagram. From the 1,334 initially planned, we enrolled 1,308 participants from the 27th of October 2022 to the 1st of May 2023, with 641 participants vaccinated in the 9 to 17 years old group and 658 participants vaccinated in the 18 to 49 years old group. Of those, 626 children and adolescents and 634 adults provided a pre and a post blood sample for the primary endpoint. Overall, we had high retention rates in this study, which were comparable between the two groups. Next slide, please. Regarding the trial demographics, we had more females than males in the study. The mean age was 13 years in the 9 to 17 years old age group and 34 years in the 18 to 49 years old group. Volunteers were mostly white, with Black or African American participants representing almost 19% of the total enrolled population. And 87% were of non-Hispanic or Latino ethnicity. Next slide, please. Now, I would like to take you through the primary endpoint antibody data. So again, the objective here is to compare antibody responses at 4 weeks after vaccine administration between the two age groups. Here on this graph, we have the day 29 geometric mean titers on the y-axis, and the 4 different influenza strains contained in the vaccine are displayed on the x-axis. The antibody responses for the 9 to 17 years old group are represented in light purple, and the antibody responses in the 18 to 49 years old group is in dark color. The table at the top of the graph is showing the day 29 GMT ratios with their respective 95% confidence intervals for each of the 4 strains. The data shows that the antibody responses were comparable between the two age groups, with children and adolescents having relatively higher responses post-vaccine administration compared to adults. This is clearly observed in the ratio of the GMTs, where the lower bound of the confidence interval is well above the non-inferiority margin of 0.667 for all strains, ranging from 1.09 for B. yamagata to 2.76 for H3N2. Non-inferiority was therefore met for all strains on day 29 GMT ratios. Next slide, please. Now we will look at the seroconversion rates. So seroconversion was defined here by having at least a 4-fold increase in antibody titers for those with an HAI titer equal to or greater than 10 at baseline, or a titer of at least 40 in those who were seronegative at baseline. The table here shows the difference in seroconversion rates between the two age groups and their respective 95% confidence interval for each of the 4 influenza strains. The differences in the percentage of participants with demonstrated seroconversion after vaccine administration between the two groups range from -0.59% for H3N2 to 14.3% for B. yamagata. As you can see from the middle column on the table, the lower bound of the confidence interval was well above the non-inferiority margin of -10% for all 4 strains. Taken together, these data showed that the primary objective of non-inferiority of the immune responses was met for all strains for both day 29 GMT ratios and seroconversion rates. Next slide, please. Moving on to our secondary objective of this study, We had 10 participants, which represents less than 1% of the total enrolled population, reporting at least one serious adverse event, and 5.1% of participants reporting at least one medically attended adverse event. None of them were determined to be related to the study vaccine by an investigator or the sponsor. No deaths or adverse events of special interest were reported in the trial. And there were no substantial differences in the safety profiles between the two age groups. Next slide, please. This slide shows the summary of expected reactions within the first 7 days. The data for the 9 to 17 years old group is presented again in light purple, and the data for the adults in dark color. The y-axis represents the percentage of participants presenting at least one solicited event, and we have data being displayed here for any severity grade and for grade 3 solicited reactions. As you can see from the graph, we had slightly fewer children and adolescents reporting any solicited adverse event compared to adults. Grade 3 solicited events overall were reported for 6.5% of children and adolescents and for 4.5% in the 18 to 49 years old group. A similar pattern is observed when we break it down by local injection sites and systemic reactions overall. In this trial, we observed that most of the expected reactions within the first 7 days were mild or moderate in nature, had an onset within the first 3 days of vaccine administration, and resolved spontaneously within 1 to 3 days. Next slide, please. So here is a summary of the local injection site reactions reported in the study. The x-axis shows the proportion of participants reporting at least one event for each particular reaction. We have mild events shown in green, moderate events in yellow, and grade 3 events in red. As expected, injection site pain was the most frequently reported local adverse reaction in 34.3% of those in the 9 to 17 years old group, compared to 40.2% of those in the 18 to 49 years old group. Injection site bruising, swelling, induration, and erythema were occasionally reported with no significant differences between the groups. The vast majority of local adverse reactions were mild or moderate in nature. Next slide, please. When we look at the expected systemic reactions, myalgia, malaise, and headache were the most frequently reported systemic adverse reactions, and these were reported in less than a quarter of participants in both age groups. And less than 3% of children and adolescents reported a febrile episode following vaccine administration. No differences in the profile of solicited systemic reactions were observed between children and adolescents compared to adults. And again, most events were mild or moderate and self-limiting in nature. Next slide, please. Regarding the serious adverse events that were reported during the study, 7 participants in the 18 to 49 years old age group reported Sorry, can you still hear me?
We can hear you now. We lost you for a few seconds.
Okay, I'll start the slide again if that's okay.
Please do.
So, regarding the serious adverse events that were reported during the study, 7 participants in the 18 to 49 years old age group reported 9 SAEs, and 3 participants reported 4 SAEs in the 9 to 17 years old age group. None of the events were determined to be related to Flublok by either sponsor or investigators based on their assessment of underlying diseases, concomitant therapy, and risk factors. Next slide, please. So to conclude, Flublok elicited robust HAI immune responses in both groups. The primary objective of non-inferiority of immune responses in older children and adolescents compared to adults was met for all 4 strains on both GMTs and seroconversion rates. The safety profile was comparable between groups. The vaccine was well tolerated and no safety concerns were identified. Next slide. This study was funded and sponsored by Sanofi. Next slide, please. Thank you for your attention.
Thank you for that presentation. Before we do questions and comments, I think we should continue with the next presentation by Dr. Vivian Dugan, please.
Thank you very much. This next presentation will focus on the severity, disease burden, and prevented burden of the 2024-2025 influenza season. As a reminder, these slides are publicly available online at the CDC ACIP meeting website. Next slide, please. The 2024-2025 influenza season in the United States captured really the attention of many media outlets and headlines. You likely have seen reports describing the influenza season as one of the worst in recent history. However, using data to assess the seasonal severity and estimate the disease burden are really essential in providing context to each influenza season, which can be unique and often is. Next slide, please. To evaluate the severity of influenza for the 2024-2025 season, we use 3 surveillance indicators across all age groups. The graph on the left is the percent of influenza-like illness, which had 2 peak weeks that were classified as high severity. The middle graph is the rate of influenza hospitalization across all ages, which also had 2 peak weeks that were classified as high severity. And then the graph on the right is the percent of influenza deaths, which had 5 peak weeks classified as high severity. So as shown in these 3 graphs, the 2024-2025 season for influenza was classified overall as high severity season across all ages and across all indicators. Next slide,
But your
please.
flu shots work.
Looking at influenza severity for this season across all ages and by all age groups, we can compare the 2024-2025 season to that of past seasons. So when we do that, this season was the first high severity season overall and by age group since the 2017-2018 season. That's the orange bars at the bottom compared to the 2017-2018 orange bars across the middle. Next slide, please. So next I'm going to describe our methods for estimating influenza disease burden to understand the population impact, to identify risk groups, and to really describe the impact on health systems. Next slide, please. Data-driven burden estimates for seasonal influenza viruses are necessary because we do not know the exact number of influenza illnesses, hospitalizations, or deaths that occur each year for several reasons. U.S. states are not required to report individual seasonal influenza cases or hospitalizations for people of any age. However, states are only required to report deaths for children younger than 18 years. Surveillance systems in healthcare settings cannot capture all influenza virus infections. In fact, many people who become sick with influenza may not seek medical care, and even those who do seek care may not be tested. People may seek medical care later in their illness when influenza can no longer be detected from respiratory specimens, and influenza symptoms are nonspecific, so individuals can be misdiagnosed with a different respiratory illness. So for these reasons, public health officials rely on influenza burden estimation and severity assessment from real-world data to understand the population impact, to identify risk groups, to describe the impact on health systems, to inform policy decisions and communication messages, and to inform economic burden and cost-benefit studies. Next slide, please. Influenza disease burden is described by clinical diseases ranging in severity from symptomatic illnesses to medically attended illnesses, hospitalizations, and deaths. Estimations are routinely completed for 5 age groups shown there on the left: 0 to 4 years, 5 to 17 years, 18 to 49 years, 50 to 64 years, and 65 years and older. In the United States, we estimate the influenza disease burden during the season and annually at the conclusion of each season. These estimates rely on multiple data sources, and estimates are not considered final until approximately 2 years following the conclusion of the season, as that is when all the necessary data for that season becomes available. Next slide, please. To estimate the disease burden for influenza, we use a multiplier modeling approach. In step 1, shown there in the middle of the slide, the influenza-associated hospitalization rate from a routine sentinel surveillance system for patients hospitalized with laboratory-confirmed influenza is multiplied by an adjustment factor for testing practices and then multiplied by the population. This adjustment factor uses survey data on the probability of one being tested for flu and then also the sensitivity of the test diagnostic being used. In step 2, deaths are calculated by multiplying the hospitalizations by a ratio of death to hospitalization and then multiplied by the population. In step 3, the symptomatic illnesses are obtained by multiplying the hospitalizations by a ratio of the number of cases for every hospitalization. And finally, in step 4, the number of outpatient medical visits is calculated by multiplying the number of symptomatic illnesses by the probability of seeking medical care when ill. And that's obtained from a telephone survey of healthcare seeking behavior during an influenza-like illness. Estimates presented today will not include deaths. Our death estimates will be available once data collection for hospitalization outcomes is complete, likely towards the end of September of 2025. Next slide, please. So this is our preliminary 2024-2025 influenza disease burden estimates for symptomatic illnesses, medical visits, and hospitalizations by age groups. The greatest number of symptomatic illnesses and medical visits were among those 18 to 49 years, but age 65 years and older had the highest number of hospitalizations. Next slide, please. When comparing this 2024-2025 season to past seasons, all three burden outcomes presented here are higher than any past season during using this methodology. These estimates are still preliminary and could change as data specific to the 2024-2025 season become complete, but the influenza disease burden on the population during the season was high. Next slide, please. We also estimate the vaccine-prevented influenza disease burden. This quantifies the benefit of influenza vaccination in preventing burden outcomes, informing communication messages around influenza vaccination, and it also identifies where improvement in influenza vaccine uptake and vaccine effectiveness could result in more public health benefits. Next slide, please. So similar to the disease burden models, the influenza vaccine-prevented disease burden models utilize additional data to produce estimates. Several components of the disease burden models, including the number of illnesses, medical visits, and hospitalizations for each age group, are used in conjunction with information on vaccine coverage and vaccine effectiveness in these models. Additionally, we use both vaccine effectiveness against outpatient medical visits, and that's to estimate prevented illnesses and medical visits, and also vaccine effectiveness against hospitalization to estimate prevented hospitalizations. And when sufficient data are available for death, we also apply that. Next slide, please. So to estimate the prevented disease burden, we rely on both the disease burden model reviewed earlier and a compartmental model that incorporates information on vaccine coverage and vaccine effectiveness. To calculate the prevented disease burden, we first apply vaccine coverage and vaccine effectiveness data from the season to the disease burden estimates. This is to estimate the risk of these outcomes to the susceptible population. We then model those risks in a hypothetical population without vaccination. And so the difference between the observed disease burden estimates from this season and the estimated burden in the absence of vaccination is the prevented burden. Next slide, please. These are the preliminary 2024-2025 prevented disease burden estimates for symptomatic illnesses, medical visits, and hospitalizations by age group. The most symptomatic illnesses were prevented among those aged 18 to 49 years. The most prevented medically attended illnesses were among those aged 18 to 49 years and 50 to 64 years. And the largest benefit of influenza vaccination was observed in the prevention of hospitalizations among those aged 65 years and older. Next slide, please. This slide shows the vaccine-prevented disease burden for symptomatic illnesses, medical visits, and hospitalizations by season, and the burden of each of these outcomes, which effectively shows the full burden of each influenza by season. When comparing the 2024-2025 season to past seasons, all three of the prevented burden outcomes presented here are higher than any past season using this methodology. These estimates are still preliminary, and again, they may change as data specific to the 2024-2025 season become available. But despite the data being preliminary, these estimates demonstrate the benefits of influenza vaccination in the prevention of illness, medically attended visits, and hospitalizations. And a dashboard with past seasons estimates of disease burden prevented by vaccination is available on CDC's Flu Burden Prevented by Vaccination website, and that link is on that slide.
This seems
Next slide, please.
contradictory to the data she previously
So in conclusion, influenza causes significant impacts on healthcare settings and disease burden in the population each season. The 2024-2025 influenza season was classified as having high severity for all ages and by age groups. This is the first high severity season across these groups since the 2017-2018 influenza season. Additionally, the estimated influenza disease burden was the highest in the United States in roughly the last 15 years. Further, influenza vaccines prevented an estimated 240,000 hospitalizations, with most in adults aged 65 years or older. Both uptake of the influenza vaccine and the effectiveness in the population likely contributed to preventing the disease from being even more severe. Next slide. And then I'd like to end and thank everyone from CDC in the Influenza Division and across the agency that supported this work.
You're saying that the shot works and you're recommending it.
Thank you very much. Do you want to just take the proposed recommendations for 2025-26, and after that we can do questions and comments?
Sure, we can keep going.
I'm sorry, I can't help but comment. I just can't help it.
Okay, thank you very much. This next presentation is the 2024-2025 influenza seasonal update and the seasonal influenza vaccination recommendations for the 25-2026 influenza season, so the upcoming season. As a reminder, again, these slides are all publicly available at the CDC and CIP website. Next slide, please. So this talk is going to have two parts. First, I'm going to provide a 2024-2025 influenza seasonal summary, focusing on the severity of the season in terms of hospitalizations and pediatric deaths. Then I'll review the proposed updates to the seasonal influenza vaccine recommendations for the upcoming 2025-2026 influenza season, and this includes 3 recent FDA approvals: the influenza vaccine composition for the 2025-2026 season, approval of FluMist, which is the intranasal trivalent live attenuated influenza vaccine for self or caregiver administration, and then the change in age indication for Flublok, a recombinant influenza vaccine from age 18 years and older to 9 years and older. Next slide, please. First, I'll review some aspects of the 2024-2025 season. Next slide, please. So the 2024-2025 season in the U.S. Was again a high severity season overall that I just mentioned, and also for all age groups. And again, it's the first high severity season since the 2017-2018 season in the U.S. Influenza viruses were the predominant circulating virus type, but influenza B viruses all co-circulated, but at much lower levels. To give you an idea of that breakdown, over 98,000 specimens tested by public health labs. Influenza viruses were represented at over 94%, with influenza A viruses being represented at about 6%. We also saw co-circulation of both influenza A, H1N1 PDM09, and H3N2 viruses. And so overall, there was a fairly even split of H1N1 PDM09, about 47 to 52%, and then H3N2 as well across the country. Next slide, please. Oh, sorry. Keep going back one. Got ahead of myself there. Thank you. Okay. So 2 of the notable indices of severity for this season were influenza-associated hospitalizations and influenza-associated pediatric deaths. With regards to hospitalizations, the 2024-25 season saw the highest cumulative influenza-associated hospitalization rates since the 2010-2011 season. And that was a cumulative hospitalization rate from October 1 of 2024 through April 30th of 2025. And that was at 128.1 hospitalizations per 100,000 populations. So for comparison, the cumulative rate for the 2017-2018 season was 102.9 per 100,000. That's the most recent prior severe season. I'll cover that a little bit more in the next slides. A second feature, again, of the severity of this season is the number of influenza-associated pediatric deaths. As of June 14th of this year, 250 influenza-associated pediatric deaths have been reported this season. This is the highest number of pediatric deaths reported in any non-pandemic influenza season since the condition became reportable in 2004. Next slide, please.
but you've gotten more people vaccinated.
This slide provides a little more detail concerning influenza-associated hospitalizations. These data are from FluServNet, which tracks laboratory-confirmed influenza-associated hospitalizations reported from select counties in 14 U.S. states. These areas include and account for about 9% of the U.S. population. As mentioned previously, the cumulative hospitalization rate reached 128.1 per 100,000 in comparison to that 102.9 for the 2017-2018 season. The chart on the right shows the cumulative hospitalization rates by season for seasons from 2010 and 11 through 2024-2025. The one exception that's not listed there is the 2020 and 2021 season. That is not depicted. That was because that season coincided with the early COVID-19 pandemic and saw historically low influenza activity across the U.S. Among the seasons depicted, the rate for the 2024-25 season has surpassed all seasons since 2010-2011. In the chart on the lower left, you can see the cumulative rate for the 2024-25 season broken down by age group. Hospitalization rates were highest among those aged 65 years and older at a rate of 403.4 per 100,000. For the lowest group, those aged 5 through 17 years, the rate was 39.8 per 100,000. Notably, about 16% of these patients required intensive care unit admission, and 6% required invasive mechanical ventilation. Next slide, please. Next, I'll provide a brief summary of influenza-associated pediatric mortality for the 2024-25 season. An instance of pediatric influenza-associated mortality is defined as a death in a person under 18 years of age, which occurred in the setting of a clinically compatible illness with an influenza-positive laboratory test, and for which there was no period of complete recovery between illness and death. Influenza-associated pediatric mortality has been nationally notifiable since 2004. So for the 2024-2025 season thus far, as of June 14th of this year, 250 influenza-associated pediatric deaths have been reported to CDC. All age groups were affected, with 0 to 5 months old accounting for 6% of deaths, 6 to 23 months for 14% of deaths, 2 to 4 years for 18%, 5 to 11 years for 36%, and then 12 to 17 years for 26%. Next slide, please. To summarize additional characteristics of this population, among 250 influenza-associated pediatric deaths reported for the 2024-25 season, as of June 14th, 42% had no known high-risk underlying medical condition, and 42% had a bacterial co-infection of a sterile site. Notably, 89% of those eligible for influenza vaccination were not fully vaccinated. This is a higher proportion than the 82% of pediatric deaths observed for the 2023-24 season. Again, this 250 deaths reported as of June 14th are the highest number of pediatric deaths reported in any non-pandemic influenza season since influenza-associated pediatric deaths became reportable in 2004. Next slide, please. Next, we'll move into the proposed updates for the seasonal influenza vaccination recommendations for the upcoming 2025-2026 season. Next slide, please. Few changes are proposed to the recommendations for the 2025-26 season. Annual influenza vaccination remains recommended for those aged 6 months and older who do not have contraindications. As previously, no preferential recommendations are made, with the exception that high-dose inactivated, recombinant, and adjuvanted inactivated influenza vaccines are preferentially recommended for persons aged 65 years and older when available. Also, all recipients should receive an age-appropriate influenza vaccine, that is, one that is approved by FDA for their age, with the exception that solid organ transplant recipients aged 18 through 64 years who are receiving immunosuppressive medication regimens may receive either high-dose or adjuvanted inactivated influenza vaccine, that's without preference over other appropriate inactivated or recombinant influenza vaccines. Recommendations concerning timing, vaccine selection, and contraindications and precautions remain the same as previously. Next slide, please. There are 3 updates for the 2025-26 influenza season, all of which reflect recent FDA approvals. The first is the influenza vaccine composition for the 2025-26 season. The second is the approval of FluMist, the intranasal trivalent live attenuated influenza vaccine for self or caregiver administration. This was presented to ACIP in April of 2025. The third is the change in the approved age indication for Flublok. the trivalent recombinant influenza vaccine from 18 years and older to 9 years and older. And the committee heard these data at the beginning of the session. Next slide. With regard to the U.S. influenza vaccine composition for the 2025-26 upcoming season, as was the case this past season, all influenza vaccines marketed in the United States for the 2025-26 season will be trivalent vaccines. That is, they will contain antigens derived from 3 different influenza viruses, 1 influenza A H1N1 PDM09 virus, 1 influenza A H3N2 virus, and 1 influenza B virus. The U.S. influenza vaccine composition for the 2025-26 season includes an update to the influenza A H3N2 component. FDA has recommended for the A H1N1 component and A Victoria 4897-2022 H1N1 PDM09 like virus for egg-based vaccines, or a Wisconsin 67-2022 H1N1 PDM09 like virus for cell-based and recombinant vaccines. This is the same as last season. For the H3N2 component, an A Croatia 10136RV 2023 H3N2 like virus for egg-based vaccines, or an A District of Columbia 27-2023 H3N2 like virus for cell-based and recombinant vaccines. This is an updated strain. And for the influenza B component, an influenza B Austria 1359417 2021 B Victoria lineage like virus. This is the same as last season. Next slide, please. Next, FluMist for self or caregiver administration was approved by FDA in September 2024 and was presented to ACIP in April of 2025. It is anticipated to be available for the 2025-26 influenza season. Consumers will be able to order FluMist for delivery for eligible recipients. Screening for eligibility will be performed by an online pharmacy based on ACIP criteria. For recipients who are approved for self-administration, vaccine will be shipped to the address provided by the person ordering. As previously, FluMist is approved for people 2 through 49 years of age. Within this age range, for those who are deemed eligible for delivery, self-administration is approved for persons age 18 through 49 years. For recipients aged 2 through 17 years, the vaccine may be administered by a caregiver 18 years of age or older. LIV3 will continue to be available for administration by healthcare providers as previously. No changes have been made to recommendations regarding appropriate populations, contraindications, or precautions. Next slide. Lastly, the third update concerns Flublok. Flublok received an additional approval by the FDA for ages 9 through 17 years in March of 2025. Previously, Flublok was approved for ages 18 years and older, so with this new approval, the new age indication is 9 years and older. This information has been updated in the table of available U.S. influenza vaccines for 2025-2026 season. Next slide, please. And then finally, these 3 changes reflect the updates for the 2025-2026 upcoming season. Just want to thank all of the people at CDC, subject matter experts, staff, and public health partners who contributed to the generation and synthesis of these very important data. Over.
Thank you very much for those presentations. And we will now go to questions and comments. Then we'll start with the voting members of the committee. Please, Dr. Hibbeln.
This is Joe Hibbeln. I have a brief comment and a question with regards to Dr. Foligati's presentation. And this regards the slide reporting the 13 significant adverse events reported in the study. As a psychiatrist, I am highly sensitive to emergent reports of suicidal ideation and intentional overdoses. And it struck me that of all the possible significant side effects, there's a disproportionate number of reports of major depression, suicidal ideation in both the 18 to 49 group and the 9 to 17 age group. And I congratulate Sonafil and Dr. Foligati for being alert and reporting psychiatric side effects, because after all, the brain is connected to the head, not only physically, but also by the immune system, and that we should be exquisitely sensitive to looking at and reporting significant side effects such as suicidal ideation and major depression. I clearly understand that this is not a randomized placebo-controlled trial, and we cannot assess the differences. I do not know as well how it was determined that these are unrelated. I don't know if there was a predisposing evaluation of psychiatric symptoms before the trial and after the trial. And perhaps this is a new emerging field of questions in immunology and vaccines and treatments. I want to congratulate Senefil and Dr. Foligati for identifying these and describing them. And my question is to whether or not the company has any interest or any plans to prospectively evaluate psychiatric conditions, especially suicidal ideation, an overdose, which I think would be a significant side effect worse than getting the flu. Do you have any plans to evaluate these significant adverse events? Thank you.
Who would like to comment? Dr. Dugan?
I would defer to Senavi, who hopefully is on the line.
Dr. Foligati?
Thank you for your question. So the first thing I would like to point out is that these events were classified as unrelated to vaccination. All of these participants with suicidal ideation, they had a past medical history of mental health disorders. We did not specifically screen for mental health illnesses as part of the eligibility criteria in this study. For the vast majority of these events, the investigators identified clear alternative triggers. And all of the SAEs that were observed in the study, we expect them to fall within the expected background rates for the respective age groups. Currently, we don't have any plans other than our standard post-marketing surveillance on safety events.
Thank you for your answer. What concerns me then is to whether or not there was a worsening of suicidal ideation in these patients, or whether it must be that you enrolled patients with suicidal ideation into the trial. Either it pre-existed or it was worsening, and so without a pre-screening, I'm not certain how you can be certain of these events being unrelated to the vaccine.
Good statement.
Thank you.
Thank you. Next is Dr. Malone.
Thank you, Dr. Koldorf. I just start off by mentioning that I will have the privilege of working with the current influenza subgroup in the future. Look forward to that. I would like to highlight a couple of things in particular relating to the two products that have been mentioned today. Regarding the Flublok product, this is truly an innovative technology. It involves the use of insect cells to rapidly manufacture the product. This is a cell-based influenza vaccine that represents really a great example of innovative biotechnology, in my opinion. This technology offers key advantages relative to historic influenza vaccine products in that egg and other cell-based products require adaptation of influenza strains and their antigens to the cell culture or egg culture environment. So you end up with a vaccine product that is, in some cases, potentially clinically significantly different from the actual circulating antigen, whereas with the Flublok technology, with baculovirus technology in general, they're able to go straight from sequence to manufactured protein in a much shorter time frame without the need for adaptation. This is a key advantage. The other product that's been highlighted here, this cold-adapted live attenuated influenza vaccine product that MedImmune has prosecuted now for years against great challenges because it doesn't fit into the kind of standard paradigm for influenza, offers significant advantages historically, particularly in the pediatric population for protection. And of course, it has the huge advantage of being needle-free. And in this case, that advantage is now being extended down to the level that it was originally intended to, that this can be provided at a much greater access and administration by less skilled personnel. So both of these, I think, I just want to congratulate both manufacturers for their commitment to innovation, appropriate innovation, safe innovation, and a well-designed non-inferiority trial. I have a specific question, and the intention here is to highlight a characteristic and address a concern that may be circulating in certain communities. I request Sanofi to address whether or not there are any fetal-derived products used in the manufacturing of Flublok. Over.
Dr. Fulakati, please.
I would like to defer the question to my colleagues on the link.
Hi, I'm CNS Murray, Medical Head for Flu and COVID in North America. So there are none of those products.
Thank you. That's a key issue for certain communities in the United States that have religious concerns. And so I wanted to highlight that this product is free of human fetal tissue derived material. I was wondering, noting that the HAI assay is the accepted correlative protection for influenza historically, but there's been long-standing interest in microneutralization data. Do we have microneutralization data perhaps as an exploratory endpoint in the Flublok product that could be briefly described?
Thank you for your question. For this specific study, we did have a seroneutralization subset. So we had approximately 400 participants who were randomized into this seroneutralization subset, and we obtained results for approximately 363 of them. So 185 in the 9 to 17 years old and approximately 178 in the 18 to 49 years old. And the overall conclusion is that we do see a substantial increase in the seroneutralization responses for both age groups. So again, we didn't observe any differences in the older children and adolescents compared to the adult responses.
Again, I congratulate and thank Sanofi for their commitment to influenza vaccination immunology and for sharing those microneutralization data. My next question has to do, is directed more towards the CDC. Historically, there has been an issue about influenza-like illness and lumping of multiple upper respiratory infections in the projections for burden of disease and reporting on that. My understanding is that the approach that you're currently using for estimating burden of disease does require an actual influenza diagnostic assay, and that this is not a lumped measure that would represent aggregate of viral URIs, but rather specific to influenza. Can you confirm that?
Thank you, Dr. Malone, for that question. Yes, these estimates are all based off of laboratory confirmed influenza for burden.
Second, that was Dr. Dugan who responded to that question. So.
Second, the 250 pediatric deaths, which is, let's acknowledge, is a modest number, fortunately. Do we have a number needed to treat regarding the endpoint of death in pediatric cohort?
May you state your name before?
Sorry, thank you. Vivian Dugan, Influenza Division. An endpoint for treatment for pediatric death, I would have to defer to my colleagues in the SME space if they could raise a hand to weigh in on that, please.
Yeah. This is Carrie Reed, I'm an epidemiologist in the Influenza Division. We have previously done that calculation. I don't have it handy, but in recent years we have not, but we can work on that and get back to you.
My understanding is the committee would very much appreciate having reports of number needed to treat for major endpoints for these vaccine products going forward. Last point has to do with this paradoxical disappearance of influenza during 2020, 2021, and then this there's the appearance of a trend of increasing pressure from influenza severity in the subsequent years. There's multiple hypotheses for why one might see a trend. Let's hope that's not the case. Does the CDC have hypotheses that they can share regarding the paradoxical sudden decrease in burden of influenza disease during the first 2 years of the pandemic? Over.
This is Vivian Dugan from CDC. I can start that answer and then defer to my colleagues in the subject matter experts space to expand. But to start, I think the COVID-19 pandemic changed a lot of general behaviors of people overall. And so there was a lot less direct contact, people moving about, people traveling. So that really decreased not just influenza activity and transmission, but a lot of the seasonal respiratory diseases that we tend to see in the viral space each year prior to COVID-19 emerging. So it's hard to rule out and tease out one specific factor that would be responsible for that, but then has everything moved forward and influenza viruses returned back to circulation along with RSV and other respiratory viruses. Really we saw this kind of co-circulation of all of these different respiratory viruses, and we plan for all of those each year to track and just keep an eye on and analyze the data from RSV, influenza, you heard RSV yesterday, SARS-CoV-2 and other viruses, so that we're really understanding the trends and some of the dynamics. But they all really remain quite unpredictable. You probably know, as a virologist, if you've seen one influenza season, you've seen one influenza season. They can be very unique and unpredictable. The rapid change and the multiple co-circulation of different types, subtypes, and different clades and subclades is often, keeping us on our toes. But any experts from the SME space want to chime in?
I thought you answered it well, nothing else to add.
Can you state your name?
Sorry, this is Carrie Reed again.
Was there comment? If not, I have one final. Shall I proceed?
Karen Reed wanted to say something or not? Okay, fine.
I think she was just identifying herself and then said she had no comment. Sorry.
Okay, I'm sorry. So please go ahead. Sorry for the confusion here. Go ahead, Dr. Malone.
So last to CDC, some members of the scientific community have concern that they're coming out of the COVID pandemic, exposure to the virus, exposure to various countermeasures. There may be a pattern of broad-based energy of some type that might contribute to increased severity of influenza disease. I infer this is probably too early, but I encourage that the agency would be sensitive to that hypothesis and provide us the data so that we can, that would either support or refute that hypothesis that there is some more broadly population-based process going on which might lead to more severe upper respiratory virus clinical pressure. Over. Did that make sense? I hope.
Who would like to respond to that? Okay, Dr. Daskalakis, please.
Thank you so much, and thanks for that question. So I'll start by just thanking Influenza Division and Dr. Dugan for a great presentation and for that great question. So I think from the perspective of the systems that CDC has to monitor influenza, that may end up being a better question for folks that are doing more pathogenesis-based research, so potentially thinking about maybe if NIH potentially has an idea around that as well. Thank you.
Thank you. We'll now move forward to Dr. Cody Meissner.
Thank you very much, Dr. Koldner. And I would also want to acknowledge the very helpful presentation by Dr. Dugan and Dr. Folagati. I have questions or comments for both of you, if I may. I'd like to start with Dr. Folagati, since he was first in his discussion about Flublok. First question I have is, why did you select 9 years of age as the lower end of age population for your comparative study with the 18 to 49-year-old? And because I would hope that you could go lower than 9 years. I assume it was because at less than 9 years, 2 doses of the vaccine is recommended for children in that category. And I'm just going to list my questions, and you can take your pick as to what you would like to address. Secondly, so the FDA has approved this vaccine based not on an efficacy trial, but on a seroconversion trial, which is the standard for influenza vaccines. But the question I have regarding that is, was there any impact from the baseline serologic status in children starting at 9 years of age on their response to Flublok? Number 2, number 3, there was a better immune response consistently among the 9 to 17-year-old subjects than among the older individuals, except for Yamagata B, which is fine because B Yamagata is no longer in any of the vaccines, and which also made me wonder why you presented data using a tetravalent vaccine that included B Yamagata along with a trivalent. And do you think there's any reason that there would be a difference in the immune response between those? The next question, did you look at cellular immunity? We don't know really what the role of T cells play in influenza, but was there any effort to look at that? And then the final question I have is, people would, I think, be very interested in a comparative trial between a high-dose influenza vaccine or cell-based influenza vaccine such as Flublok and some of the standard egg-based vaccines. And can you anticipate any comparative trial that we might see in the future. So I'll stop there. It's probably an unfair number of questions, but I also have a comment for Dr. Dugan. So I'll stop at this point. Dr. Kuldorf, and thank you.
Thank you. Please, Dr. Foligati.
Thank you very much for your questions. These are really good ones. So I'll start with the first one. So why have we chosen the 9 years and above? So you're absolutely correct in your interpretation. So the recommendation that we have is for a single dose vaccine administration from children aged 9 years and above. The assumption we have is that by that time, children from 9 years of age and older, they're expected to have similar immune responses to adults. So that's why in this study we stopped at 9 years and above. With regards to your second question, so we did have a subgroup analysis where we looked into the influence of baseline serostatus and also whether the, if some participants had received an influenza vaccine in the previous season, and the overall conclusions remained the same. Regardless of serostatus or previous vaccination in the preceding year. Regarding specifically about the fact that yes, we did observe better immune responses in children. They also had higher baseline titers, but when you look at the fold increase, so their ability in amounting in immune responses compared to adults, the fold rises are highly comparable. And then the other question I had was whether we've looked into cellular immunity. No, we have not looked into cellular immunity in this trial.
And the last question about a head-to-head comparative trial with Flublok and some of the other vaccines.
Yes, thank you for that question, Dr. Weisner. We have got data on hand of comparative comparison of Flublok versus standard dose vaccine, most notably a cluster randomized study that came out of Kaiser Permanente, and we're happy to share that data and all other data we have with you. It has been presented to this group before, the Kaiser data.
Okay, thank you. And can you comment on the results or briefly?
Yes. There was a relative vaccine efficacy in favor of Flublok versus standard dose.
And that was a serologic study, not efficacy?
No, it was an efficacy study.
Okay. Thank you. I will have to look for that reference.
We're happy to share that with you following this meeting.
Oh, thank you. And in terms of the immune response to a trivalent versus a tetravalent vaccine, they should be similar.
Yes.
Okay. Dr. Dugan, I really appreciate the data that you presented. It was wonderful. I want to make one comment. A lot of times what I hear is that people don't want to get the influenza vaccine because it's not as effective as other vaccines that we're accustomed to living with, such as the measles vaccine, which offers excellent protection. And I think the point that you made that's so important is that even though efficacy may be considerably less from the current generation of influenza vaccines, the fact that probably 10 to 15% of the American population, that is between 30 and 40,000, or 30 and 40 million Americans develop influenza illness, even if the vaccine has limited efficacy relative to other vaccines, because the number of people who get infected is so large that even a relatively small benefit has an enormous impact on the public health of our country. And so you may want to comment on that. And then, but the question I have for you is, can you tell us, have you collected data on what % of influenza vaccines this year were administered at home by individuals over 18 years of age with flu mist? How well has that has that been accepted? Just thinking about going forward. Thank you very much.
Thank you very much, Dr. Mars. I really appreciate your questions. I think for your first comment, just to add that based on our estimates, there would have been approximately 1 million hospitalizations without the vaccine this season, 2024, 2025. So really underscores the importance of vaccination overall for influenza burden. As far as the self-administration for flu mist LIV, that is coming for the 2025-2026 season, so it is not yet available, but it is expected to be available. I'm not sure if there's anyone from AstraZeneca on the line that might want to provide any details there.
It doesn't seem so. We are running a little bit behind time, but I want to make sure that if there are any members of the voting members of the committee who has not spoken yet, if you have questions or comments, please, Dr. Diwan.
So thank you again. Thank you for the presentation and the extensive analysis. The first thing I would like to say is that it would just to anchor the sentiment of conducting clinical trials to compare the efficacy of different vaccines. I think it's important to continue to do that. I do have a question that has to do with what burden of influenza is being averted by vaccination, and which is also related to how do we assess the vaccine efficacy year to year. I just want to point out that it's a rather challenging task. So I want to ask the colleagues on the CDC whether, in addition to the existing approaches, are we using any negative controls approaches to understand potential impact of healthy vaccinee effect? And the second thing is that when I looked on your model to assess the aversion or what would be the burden without vaccination, it seems that it's monotone in the observed number of hospitalizations. And I think if that's the case, I think that there is some potential concern here, because if I look on the overall, if I consider the burden on hospitalizations is a function of the overall potential burden and the efficacy of the vaccine. So if the observed burden is going up, it could be for two reasons, maybe both. One is that the initial burden, the base burden is higher, and or that the vaccine is maybe not as effective on that particular season. We know that that could vary. So I wonder how, it would be good to get your thoughts of how do you think about those kind of concerns, and what can we do to get more precise answers. Thank you.
Thank you. Vivian Dugan, Influenza Division, CDC. I'm probably going to defer to a lot of my experts who run these models on the line, but I can say that overall, we do look at our models and we do test and stress test them and look at other ways to improve them overall, and new data types to try and, again, give us more clarity, more granularity overall. But in thinking about, of course, what goes into overall burden, there's certainly merit that there are many factors that will play a role on the effectiveness of the vaccine, uptake of the vaccine, attitudes towards the vaccine, the timing of the season, the co-circulating viruses, the predominant virus, the antigenic relatedness of the vaccine to what's circulating. So there's a lot of activity to think about overall. So with that, but I'll ask our modelers on the line to chime in, please.
But you can say that.
Yeah, hello, Dr. Carrie Reed from the Influenza Division again. And thanks for your question. So yes, that is correct. That there's three components, as was mentioned, into the models to estimate prevented burden. The burden that's observed during that season, which varies from season to season, vaccine coverage during that season, and then the effectiveness of the vaccine as measured during that season from the vaccine effectiveness studies that are conducted that year. And so it's true that in years where the burden is higher, because there's more flu circulating in the population that season, even the same effectiveness of the vaccine may have a bigger impact in terms of the total number of averted outcomes, because there's a greater incidence in the population, a greater risk influenza to the general population.
Yes, I guess I just want to point out that there is some endogeneity here, right? Like we should recognize that potentially the burden that we see is a function of the efficacy of the vaccine. So I think maybe my suggestion that maybe we should try and put some effort to think about what else we can do to try and get these models more precise, because I'm concerned that some of these estimates might be coarse and maybe not precise enough to understand very important issues that we want to monitor over time. Is how what is the efficacy of these vaccines, and how do we get better in dealing with a very serious illness?
Thank you.
Thank you so much. We are running behind time, so we're going to have just one more question, and that's from Dr. Jason Goldman. Please, thank you so much.
Thank you, Jason Goldman, American College of Physicians. Observation and question first. Just want to point out 250,000 pediatric deaths is not a small number, especially if it's your own child dying from a vaccine-preventable illness. But number two, as far as the impact of flu, it would be helpful to look at modeling studies on the financial burden of the infection and what is averted when you consider not only the cost of hospitalization, but the impact on the healthcare system, how many patients are seeking care in clinics and urgent care, how that is displacing the amount of available healthcare for those who are sick with other conditions that could have been seen if patients did not have to go to clinics, urgent cares, hospitals for flu, as well as the individual's loss of revenue, the loss of ability to care for those that they may be responsible for, and caregivers. Giving a vaccine to those who are younger, who are taking care of the elderly, is also a consideration. So those economic modeling studies and financial impact would also be helpful, because vaccinating for the flu not only decreases hospitalization and death, it also saves lives and also has a tremendous benefit to preventing a huge financial burden on the healthcare system, to allow more patients to be seen and to be healthier, which is our goal. So I would appreciate that the committee take that into consideration as well. Thank you.
Thank you, Dr. Gorman. And Dr. Dugan, please.
Sorry, Dr. Gorman, just to correct, and if hopefully I did not misspeak, but it's 250 influenza-associated pediatric deaths this season, not larger than 250.
Thank you so much. It's now 10:15. Before the next presentation, we are going to take a 15-minute break. So we will reconvene at 10:30, and I would like to thank all the presenters and the excellent discussions we've had. Thank you.